Hi everyone, welcome back. We're going to look at a second project called NetProbe, and we'll look at how it goes through the different analytics building blocks. And NetProbe is a system that detects fraud on online auction. And this is work that was published in WWW 2007. And the problem it's trying to solve is to find the bad guys on eBay, such as people who do not deliver your item even though you pay them. And non-delivery fraud is a very common auction fraud. It's still one of the top online crime. The way that NetProbe works is to look at the connections among buyers and sellers on eBay. So we connect a buyer with a seller if, say, the buyer has purchased something from the seller. So that means we're trying to build a graph or a network that connects these people on eBay. So in this graph, this graphics here, you will see that each node is a person, and the person can be a buyer or seller, and then the links would be transactions. So how do we find bad guys on eBay? It turns out bad guys are very smart, and they will fabricate their reputation on eBay. So if you ever used eBay before, you know that there's a number next to your account, which is the number of positive feedback you've received minus the number of negative feedback you've received. So that means higher the number, the better. And what the bad guy does is try to make that number as high as possible by creating different kinds of account. Specifically, they create two types of account. One we call the fraudster account in red here, and then a compass account in yellow. The fraudster account are the ones that would trade with the victims. So that means these are the ones that would defraud the victims. And the compass accounts are the ones that look pretty legitimate, and they would trade with honest people. But then they would also occasionally trade with the fraudsters. And these are the links between the yellow and the red nodes here. And these kind of transactions are what I would call the heavyweight transaction. And these transactions would involve expensive items like LCD TV, laptops, and so on. And the reason that they want to do this heavyweight transaction is to make the fraudster look as good as possible. So imagine you're someone who want to buy something from, say, one of the red account here, the fraudster account. What would you do? You would go and look at the history of those fraudsters, and then you would say, has this person paid on time? And because of this heavyweight fake transaction between the accomplice and the fraudster, you will see that, oh, actually they pay on time, and that's a very good amount. And then you would trust that, or you would think that the fraudster account is actually trustworthy. So after creating these two types of accounts, then the fraudster account, the red one, will start to sell a lot of things. So by sell in quote, because they would never intend to deliver the item to you. So that is how the non-delivery fraud work, which is one kind of the fraud. And you can imagine there are many, many other kinds. So what that means is that if we want to detect auction fraud or non-delivery fraud, here what we want to do is try to find this pattern between the fraudster account and the compass accounts. And technically, we actually call it a near bipartite core. And bipartite because there are two types of accounts. It's a core because it's a subgraph within the whole graph. And it's near is because there are actually some missing edges. For example, you look at here that there is actually one missing edge between a red node and a yellow node. And the reason that this exists is because this is a side effect of how the fraudster, the actual fraudster, would work. It just turned out that the transaction would look like this near bipartite core. So now the problem of detecting fraud becomes how do we flag this kind of pattern from the whole graph. So what we do is we feed this matrix into the belief propagation algorithm, and it's able to flag actual fraud that people reported. So if you ever used eBay before, you know that there's an online website dedicated to the victims where they can report or tell other potential victims that, these are the accounts that defrauded us. And the red node here are the ones that people reported. So what NetProbe is able to do is sort of also flag other potential fraudster account or accomplice account that people didn't know yet. And this was very effective. And when we run it, we flag a lot of these scores. And also when we publish it, we got a lot of attention from press like New York Times and also Wall Street journals and so on. We also built a user interface to help people understand what is the patterns that are detected. So specifically, how do these connections look like? So here we're showing one of the detected cores. So the user can mouse over the node and then understand, OK, why do you think that this person is flagged as a fraudster? Who are the accomplices? And so on. So what did NetProbe go through? Which building blocks did it go through? We need to do a lot of the scraping from eBay, so data collection. And because of that, we also need to do a lot of the cleaning. And all the data came from eBay, so we did not need to do data integration. But we spent a lot of time on doing the analysis, specifically on designing the detection algorithm using belief propagation. And you just saw we have a visualization to help people understand the detection results. And in the end, it's also an academic project. So we did a paper, we gave talks, and now I'm covering it in lecture. So we did not release NetProbe. If you want to know a lot more details of NetPro, this is the full paper that we published at WWW 2007. So what you just saw is another example called NetPro, and it went through different blocks in the whole pipeline of analytics building block.